Hi there. Welcome to this webinar on how to protect your applications in 15 minutes by Zerto. I'll just give it another few seconds waiting for everyone to join before we get going. And as we're doing that, I'll just give you a quick introduction about myself. My name is Joshua Stenhouse and I'm a technical evangelist at Zerto. I've been with the company over 3 years now, and before that I was actually an end user of Zerto where I bought, installed and tested Zerto myself. So everything that I'll cover today is both from the perspective of a customer and now me working for Zerto. Now, before we go into actually how you protect your applications with Zerto, I think it's important to set out the reason behind Zerto and what it's actually doing. And at Zerto, we discovered that replication and BCDR in a virtual environment was being done in the wrong place. It was being done between your matching storage arrays in your two data centers, and you were replicating on a storage and LUN basis, and then having all the complexity on top of that of trying to match which VMs are in which data stores, and then use some form of orchestration on top of this to try and map the storage into the virtual environment, where the key challenge is actually just protecting your virtual machines. So at Zerto, we moved the replication up into the hypervisor to become part of the software-defined data center by bringing the first enterprise hypervisor-based replication and recovery solution to the market. And you can see the trend throughout the industry of making everything software-defined to truly realize the benefits of virtualization. There's no point virtualizing just your applications and then having every service around them, such as firewalls, the replication, load balancers, all in a physical world, because you're never going to truly realize the full potential and benefits. So that is what Zerto is doing by introducing our solution, Zerto Virtual Replication, that is 100% virtual aware, in that we see the day-to-day changes that happen in your virtual environment. As of 4.0, and a lot of what I'll talk about in this webinar is with regards to Zerto 4.0, and that'll be released at the end of this quarter. So I'm going to talk a bit more about our upcoming support for different hypervisors, which is why Zerto is software only, and because it's software only, we are completely storage agnostic and soon to be hypervisor agnostic. And I'll go into more detail in that later on in the presentation. But most importantly of these points here, Zerto is enterprise in class. And what do I mean by that? I mean that we will never impact the performance of your protected applications and virtual machines. I'm sure you'll agree one of the reasons you're on this webinar is to find out how you can protect these applications, but I'm sure you'll agree that if you are slowing these applications down in order to protect them, then often it's not worth protecting them at all. And examples of that could be some snapshot-based replication that hinders the performance by continually taking snapshots. Zerto does not use any form of snapshots, which is one of the reasons amongst many, which I'll cover in this webinar, as to why we're enterprise in class. So what I don't want to do is keep you online for 40 minutes before I actually give you the answers as to why you join. So I'm going to give you a very brief summary of how easy it is to protect an application in Zerto, and this is exactly why you can do it in just 15 minutes. And then once we've done the overview, I'll go into more detail in each step, so how you actually do it, and then I'll show you an example in my live demo. So you have your data centers, some virtual machines that form your applications, and you need to protect them. The first thing you do is install your Zerto Virtual Managers, which is your interface for controlling the disaster recovery and replication. You then deploy the virtual replication appliances, which sit on each of your ESXi hosts. And then finally, you select the VMs that form your application, you put them in a Zerto protection group, and then everything else is handled in the background. So you don't have to configure any replication agents on each individual VM. You just install the managers, deploy the appliances, select the VMs, and away it goes. That is fundamentally how simple protecting an application is in Zerto, which is why you can do it in just 15 minutes. So to go into a bit more detail in this process, we'll start by listing the different data center topologies that we'll support in Zerto 4.0, where we have our standard VMware to VMware replication between two vCenter servers for disaster recovery. In 4.0, we're adding support for Microsoft Hyper-V, where from your system center, you can also install a Zerto manager, and will support replication from VMware vSphere to Microsoft Hyper-V. We'll also support replication between Microsoft Hyper-V servers, introducing the first real enterprise-class DR solution for a Microsoft Hyper-V environment. And then finally, we'll support replication from Microsoft Hyper-V back into a VMware vSphere environment with automatic VM conversion on the fly. You don't have to wait for any post-processing because Zerto just does block-level replication in the hypervisor. Whatever the target native disk format is, Zerto is going to use. By the way, if you have any questions, please put them in the question box and I'll answer them as we go along. You don't have to hold back. For cloud topologies, in Zerto 4.0, we'll support replication from your on-premise site into a managed cloud provider. And here are just a few of the examples, but you can see there's up to 150, and if you go on our website, you can certainly find a high number of those. Our managed cloud providers also use Zerto to replicate inside their cloud if you don't manage your own VMware infrastructure, for example. And then in Zerto 4.0, we're also going to add support for replication directly from your on-premise environment, whether it's VMware vSphere or Microsoft Hyper-V, up straight into Amazon Web Services. For this demo today, I'm just going to cover the just going to cover VMware vSphere and Microsoft Hyper-V. And for your data center, the minimum requirements are SCVMM 2012R2 or vCenter 4.0 Update 1 onwards. And you have to have this management server because this is what the Zerto manager uses in order to manage the orchestration and basically integrate into your virtual environment. You need to deploy a management Windows VM on which we're going to install the Zerto manager service that needs 2 vCPUs, 4 gig of RAM, 40 gig of disk space, and 1 static IP address. In terms of the underlying hypervisor, it should be Server 2012 R2 Hyper-V or ESXi 4.0 Update 1 onwards. In terms of the storage, because Zerto is software only, you can use any direct attached or shared storage. It doesn't matter whether it's EMC, Dell EqualLogic to local disk or NetApp. From a Zerto perspective, it really doesn't matter. And then finally, in terms of the bandwidth between the sites, you need a 5 meg link both up and down as a minimum for the replication traffic. Once you've met these requirements, the next step is the installation of the Zerto Manager service onto the management VM, which you then pair to your system center or virtual machine manager, which gives you access to the Zerto GUI via our vCenter plugin, a PowerShell or REST API, or very simply point a web browser at the address that you can see there, and you'll have easy access of management of your disaster recovery. From the Zerto Virtual Manager interface, which is where you then manage and deploy your replication, you deploy the virtual replication appliances. And these are installed 1 per host, and we recommend 1 on every host in a cluster so that as you vMotion VMs, we can continue the replication. There's no impact of this VRA deployment, and they're very small in size. There's no maintenance mode required, no downtime. They consume 1 vCPU, a maximum 3 gigabytes of RAM, 12 gig of disk space, and they use 1 static IP address per appliance. We then need to pair the Zerto virtual managers together to enable the replication between your data centers. We can then configure the site-wide throttling on a time or permanent schedule so you can limit the maximum amount of replication traffic, and the replication traffic will use our built-in LZ4 compression engine, which we typically see a 50 to 80% compression real-time of the replication traffic. You then configure the target site port groups and vSwitches that you want to use upon failover and failover testing And then finally, in the DR site, you need to ensure that you have at least 30 gigabytes free in your target data stores. And in terms of the total space, you should have the same size of the source VMs plus up to 15% for data change rate. So just as you configure a snapshot reserve on your storage LUNs, with Zerto there's no snapshot reserve, there is just a journal size. And so this will automatically grow and shrink depending on the data change rate, but we'll come back to that later on in more detail. Once you've done that process, and as I'll show you in the demo, deploying the VRAs is extremely quick, no downtime, and you'll start to understand how you can do it within 15 minutes. The next step is configuring your VM replication. And what we see in many enterprise environments is that your typical large-scale applications do not consist of individual VMs, even though some can. What they typically consist of is multiple virtual machines, such as a database, index, file, web server, load balancer, that all form together to create your enterprise application. So in Zerto, you put them in what we call a virtual protection group, which is a consistency grouping of the virtual machines on a per application basis that ensures they are all recovered to an exact consistent point in time. They're not going to be at different timestamps which can break the recovery operation. You can set the boot order of the virtual machines to ensure that, for example, the database VMs come online first, ensuring the recovery works. You can select your target site mappings in terms of which data stores, hosts, and clusters you want the virtual machines to be registered against when failing over, as well as the SLAs around the continuous replication, so that if there's any breach in the SLAs defined, we will let you know. You then configure the storage in terms of do you want to pre-seed, so you don't send all of the changes across the wire, and you can configure the ability to automatically change IP and MAC addresses on the fly. And then finally, you can configure long-term retention of the data, and you can specify Zerto to keep backups of your data in your recovery site to a separate storage array, for example, to ensure that you can always recover no matter what. Once you've gone through this process here, the virtual protection group is created, the application data is synchronized in the background, and then Zerto gets into a state of continuous data protection, where we're replicating compressed block-level changes as they are occurring near synchronously, which delivers a recovery point objective of seconds on a per VM and application basis. So without installing anything inside the VMs, anything that actually interacts with the application itself, you can have the continuous block-level replication using our replication appliance technology. It's from any to any storage with no snapshots and therefore no performance impact. And we keep a journal of all the changes in the recovery site, which allows you to rewind to any point in time up to 5 days in the past. And the journal itself is a thin VMDK on a per VM basis that automatically resizes to meet your SLAs. So if, for example, you set to keep 24 hours of change and 20 gigabytes changes in that 24 hours, then the journal will be 20 gigabytes. If 3 days later you only have 1 gigabyte of change, then Zerto will resize that journal back down and reclaim that space, which makes it extremely efficient long-term in larger environments because you're not wasting disk space on journals that were previously inflated, which is what you'd have with snapshot reserves and snapshot-based replication between your storage arrays. The obvious benefits of the continuous data protection is that you can simply rewind back to any point in time, and you can see the ability to select the many thousands of points in time in the checkbox on the left-hand side, which means you're not just protecting your application against a site disaster, you're protecting your application against logical failures such as a virus or a database corruption or a user error, because you can simply rewind to the point in time a few seconds ago, not your last backup or snapshot. We do support both crash and application consistent points in time, giving you the choice of either in a failover scenario. And most importantly, the point in time that you select here allows you to recover your multi-VM application to the exact same point in time, which is why we're saying that we're allowing a consistent application recovery. In terms of the disaster recovery automation, once your applications are protected, we give a recovery time objective of just minutes. In just a couple of clicks, we will bring the virtual machines online in the recovery site in the correct order and automatically change the IP and MAC addresses if you set to do that when configuring the protection group. We also give the ability to click to test anytime, and we'll bring the virtual machines online in an isolated network, allowing you to test how long it takes to recover the applications, that the data is consistent, and that it actually works. But importantly, we do this with no impact in production and no break in the replication, which means that this doesn't just have to be for DR testing. You can use the failover testing for short-term testing of, for example, Microsoft patches or your application upgrades. And if you want to create long-term test environments for maybe dev test, we have an off-site clone feature which allows you to take a point-in-time copy of the VMs in your recovery site and then have them registered in the inventory, complete clones to a new data store from that timestamp, allowing you to do whatever you please with them. And then finally, for automation, failback with Zerto is a single checkbox where we automatically reverse the replication and start sending the changes back to production. You don't have to resend all of the data. You don't have to recreate all of the protection groups. With this single checkbox, your application is automatically replicated back to the primary site. Here we can see the new Zerto 4.0 interface, and from this single interface you can manage both VMware vSphere, Microsoft Hyper-V, and AWS recovery. You don't have to have different skill sets for managing the replication and recovery between each hypervisor, which obviously reduces complexity and management overheads. I have a quick question from Igor, and he's asking, can Zerto do a replication like VMware SRM to change the roles of primary and secondary sites? So I believe Igor is asking the question in terms of, can you fail over, configure the reverse protection so now your secondary is your primary and vice versa? Then yes, you can. That is exactly the role of the reverse protection box, where all of a sudden what was now your secondary site is now your primary, and what was your primary site is now your secondary because you checked the reverse protection checkbox. Please confirm, Igor, if that answers your question or not. Hopefully it does. Here you can see on the interface we have site-wide statistics in terms of the total amount of protection groups that we have protected, so our applications, the number of VMs within those protection groups, the amount of data, application data protected, the average recovery point objective being achieved across the board, and then the real-time compression on any replication traffic. And I appreciate this is a screenshot. I'll show you this running for real in a demo in a short while. One question from, I believe, one second, let me expand that, is Raul, and it says, can we create a paused virtual protection group? Now, if anybody asks this, I'm usually interested as to why, but yes, you certainly can create a protection group and then pause it. But often I ask why, because usually the answer is this is not a very important application, therefore I want to pause it for X amount of hours during the day. In Zerto, we actually have a priority setting which allows you to control the QoS and the priority of the replication traffic for that application. So if it's an app that's not that important that you want to pause for the majority of the day, then you should simply set it as a low priority protection group, and if the replication traffic is available, then we will replicate any changes to that app. If the replication traffic bandwidth becomes constrained, then we will deprioritize that low priority application and prioritize the high priority ones. Therefore, you have the same effect, but the added benefit that if the bandwidth is available, it's replicated. Can the protection process be scripted is a question from Alan, and yes, it certainly can. This can be done through our REST API. And in the new Zerto 4.0 GUI, we have workflows for bulk creation, which means that rather than taking multiple clicks to edit different IP address settings, for example, and port groups, in the new Zerto 4.0 GUI, in larger environments, we've made it much simpler. I won't cover it in the live demo today, but one important thing we have here is our cloud management interface, what we call a Zerto Cloud Manager. And this is actually built into the software, it's included in the licensing, and it is actually our manager of managers, whereby if you had, for example, 20 different sites with 10 of them vCenters, 10 of them system centers, then from the single pane of glass, you can see all of your connected sites, all of your protected applications, and see alerts and alarms across the board, giving you a true global enterprise view of your BCDR between multiple sites. It allows you to provision and manage multi-tenancy for BCDR, whether this is between your data centers or maybe for DR as a service or your internal organizations, where you can actually then give them, self-service, and this includes BCD integration with user permissions, and you can also see the cloud-wide protection statistics, alerting, and service profiling. So what I'd like to do now is cut across to a live demo so as not to bore everyone to death with the PowerPoint. And I'm going to show you the VRA deployment process, a ZVM overview, and how exactly to protect your applications in just minutes. If you bear with me while I just wait for this to load. So hopefully you can all see my screen now. And just to give you an overview, I have two data centers here, and in my demo lab, I'm just going to show you replicating from VMware to VMware, where here I have a Boston VMware Zerto manager, and I'm replicating from Boston to my London Zerto Virtual Manager, where I have a second VMware infrastructure. And just to show you what that looks behind that, if I go to my vSphere clients, then here you can see I have my Boston DC1, where I have a vCenter server, a Zerto Virtual Manager, and some virtual machines to protect, including my CRM App4 database file web server VMs, which is the application that I'm going to protect in this demo now. I'm going to protect this application to my London data center, where I have a second vCenter, a second Zerto Manager, and some more virtual machines. And the obvious reason that I have two vCenters and two Zerto Managers is simply that if I lose my primary site data center, then I have a Zerto Manager and a vCenter to log into to initiate the failover process. If we come back to my Boston data center, then here you can see the dashboard that we just saw in the presentation, where I have the real-time statistics, and this is the actual recovery point objective for across all of my applications that I have currently protected, with the real-time compression of any replication traffic. For deploying the virtual replication appliances themselves, it's done from the Setup VRA tab that you can see here, where you simply select each ESXi or Hyper-V host, click on the new VRA button, we give it a root password, a data store, a port group to use for the replication traffic. We assign the amount of VRA RAM, which is a maximum 3 GB. We give it a static IP address, click install, and Zerto will automatically deploy the OVF appliance to the host. No maintenance mode, no downtime, extremely simple. Once you've deployed your virtual replication appliances in both sites, and you've paired your Zerto virtual managers together so that on this Sites tab here, you can see I have my Boston data center Zerto manager paired with my London one. Then the next step is to configure the virtual protection groups so you can protect your applications. And a quick question here from Alan, and it's, can you replicate between clusters in the same vCenter or VMware instance? So yes, you can. It is an advanced setting, and it allows you to select a separate host within the same system center or vCenter as a replication target. So if we click on Actions and then Create Virtual Protection Group, I'm now going to take you through the process of protecting my application. I'm first going to specify the name, which is CRM App 4, and here you can see the priority and quad setting that I mentioned, where depending on the SLAs defined, you can then set where and how you want to prioritize the replication traffic of this application. We then need to select which virtual machines that form this application that we want to protect. And this is simply a list of all of the VMs in the source vCenter that are on hosts with replication appliances. So I'm going to select these 3 VMs that together form my CRM application. I'm then able to define the boot order of these VMs so I can ensure that, for example, the database VM comes online first in front of the file and web servers using the boot delay and the group setting here. Once you've decided on the correct boot ordering for the application, then we need to select what we want to replicate to in terms of the recovery site. I only have 2 sites paired here. You can have multiple Zerto managers paired, allowing replication between any different number of sites that you desire. If you had enabled intra-site replication, as asked by Alan, then I would actually be able to select the recovery site as Boston, so from Boston to another host within Boston. Now I've selected London, I'm going to be given a list of all of the hosts and clusters and resource pools in this target site that I can select as a replication target. I'm going to replicate to my recovery cluster, and now I'm given a list of all of the storage data stores presented to that host. I then need to select the service profile, and you can create custom profiles or you can apply default ones from your Zerto Cloud Manager. And just to talk you through a few of the settings here, the default journal history is the time frame on which to keep changes for in the recovery site, allowing you to rewind back in time. And you can see it's a maximum of 120 hours, which is 5 days in the past. And if we click Advanced, then you see the ability to change the default journal data store. By default, it's stored in the same target data store as the VM's target. And you can also configure a maximum hard size limit and a warning threshold. And what this will do is Zerto will still automatically resize the journal depending on the data change rate, but we will never go above this maximum size specified here. If, for example, you set to keep 24 hours and a maximum size of 20 gigabytes, and 20 gigabytes changes in 2 hours, then this protection group and application will be breaching its SLA, and therefore we will let you know by our alerts and alarms that you're now breaching the SLA defined. The target RPO alert is simply an alarm. It is not a schedule. And all this defines is that if the recovery point objective goes above the settings set here, then again, you're breaching your SLAs, and we will let you know. A typical example might be the site link has gone down, therefore we cannot replicate any subsequent change, and the recovery point objective will steadily start increasing until the link comes back online, and then we will immediately get back in sync with the latest change box and get back down to a recovery point objective of seconds. Test reminder is just an alarm that if this protection group hasn't been tested for a failover, we will let you know. We can then configure the target site storage, and here you will see every single VMDK in each VM, and you can specify different VMDKs to be stored in different target data stores, allowing you to be extremely granular in how you configure this protection. If we click Edit Selected here, you can see the ability to use preceding, where if you select a target data store and a copy of the VMDK, we will just send the changes. We can go thick to thin provisioning if you so wish. And the swap disk feature is very powerful for protecting your SQL servers, because what it actually does is if you put your temp DB on a separate VMDK, we will do an initial synchronization of the disk so that the application and the OS require no manual intervention in order to recover, but then we don't waste any bandwidth replicating subsequent change, which means we reduce your replication traffic for any application using SQL by 50%, as well as using 50% less journal space and 50% less writes being processed by the source replication of points. We then need to configure the recovery site networking, and for failover move network, you should select a production port group that you want to connect the virtual machines to when failing over. For failover test network, you should select an isolated port group that can be routable between the hosts, but should have no routing to production to ensure that there's no production impact of your failover testing. Then we select a recovery site vCenter folder, and this is just a list of all of the VM folders in the target site vCenter. And here you can see scripts where if your application requires any custom configuration as part of the failover operation, all this does is run whatever script you specify on your target site Zerto Virtual Manager in either a failover test, move, or failover operation. A quick question from Tom Snyder here. If you resize the source VMDK, will Zerto detect the increase or decrease without having to start the replication over? That's a great question, Tom. Zerto will automatically detect the resize, and we will just scan the new blocks that have been added to that disk and get back into the continuous replication state. It doesn't send all of the data back over, just the new blocks added. We then need to configure our recovery site network mappings, and here you can see every single network adapter inside every single protected VM in this protection group. You can map them to different port groups, and you can also select a new IP address for Zerto to automatically change the VM to as part of a failover move or a test operation, as well as assigning a new MAC address. By default, they will stay exactly the same, and this operation requires VMware tools to be installed. Then the final selection screen we have here is backup, and what this allows you to do is you can configure long-term retention of the data, and with this target repository setting, what this allows you to do is map a network share or a disk's a local disk or raw device mapping to your target site Zerto Manager, and then based on the retention settings you set here and the schedule, we will take backups of that replicated data to that separate storage on the schedule defined. And the two benefits of this are, one, that you can keep the data longer than 5 days. In fact, you can keep it an infinite period. And two, it means that if, for example, your target site storage, your main storage array in your target site was to go offline, or you lost your target site vCenter or Zerto Manager, with this offsite backup, you have a portable compressed backup file of the replicated data in your recovery site, restorable to any Zerto Manager, any vCenter, any system center, that guarantees you can always recover. So I actually like to call this feature, rather than backup, I call it always recover. For this demo here, I'm not going to configure this, and if I just click next, then we have a summary of the operation, and then we click done. And what Zerto is now going to do is create the protection group, read all of the source VMDKs in this application, compress, replicate, and then create a copy of them in the target site. And when that's finished, it then gets into the continuous data protection state, which if we click on the Virtual Protection Group tab here, for each of my protected applications in this actual recovery point objective column, then you can see a real-time recovery point objective of just seconds. And I'll zoom in just so you can see that a bit better. So you can see, without having to install any replication agents inside the VMs themselves, select the VMs, put them in a protection group, and then we get the real-time replication using the replication appliance showing a data loss of just seconds. Now, typically what we see is once you've protected your applications and you have them in this continuous protection state, the next step is to perform a test failover to simulate what would actually happen in a real DR situation if you were to try and recover one of your applications. So here I have a few of my applications protected, and I'm going to test a failover on my SQL Server Virtual Protection Group, replicating from Boston to London. Here we can see the checkpoint selection box, which allows you to select the previous points in time to failover or test failover to. Apologies if there's any delay in showing this. So now you should be able to see that you have the increments, as you saw in the presentation, of every few seconds. And the cool thing about this journal is that it maintains the right order fidelity. So all the VMs are recovered to that exact same point in time, and you can liken it to the equivalent of SQL log shipping, except there's no SQL logs that are being shipped, it's just continuous block level replication. A question from Tom, can you restore a specific file or is it the whole VM? It's actually, right now in the current version of Zerto, you restore the entire protection group. So we recover on a per protection group basis. You can use an offsite clone or a failover test to then pull an individual VM or a file. But in terms of this restoration workflow here, it is an entire protection group. On our roadmap, I can share with you that we are currently planning on introducing the ability to recover files later this year, but right now it is a per protection group basis. But the cool thing is that when we do introduce the workflow for file level recovery, that you'll have the unique ability to restore files from thousands of points in time. And I'll be honest, you can do that right now in this demo because you can do a failover test, have the VM registered online, and you could pull a file out of it. There's a question from Hamid, which is how replication reacts to features like DRS, SDRS, vMotion, and HA. Well, that's a good question, but with the replication appliances, because you have one on each host, as you have a vMotion, HA failover, or DRS between the hosts, that is why you have the replication appliances on every single host in the cluster, so Zerto can continue the replication, which means you don't have to make any changes in the protected VMs. We continue the replication, and it just works. For storage DRS, again, exactly the same. If you storage vMotion the disks to a different data store, Zerto's still replicating, still protecting. There's no change needed. If I click Next, then we'll have the test failover option. And if we click on test failover and come across to my London data center, what we're going to see is Zerto automatically building the failover test environment, where you can see with the tasks at the bottom, we have a new VM created for my SQL Server -testing recovery. It's going to be connected to an isolated port group so that it cannot communicate with production. And it will be powered on in a moment, so I can log into the console, check the data is consistent, the services are loaded, and that the database is actually there. But just as we wait for this, the most important thing to show you is if I come back to my Boston vCenter and we look on the left-hand side in the inventory, you can see my SQL Server 1 VM is still powered on in production. We haven't shut it down in order to perform this test. And if we go into the Zerto Virtual Manager interface, here you can see we're building the failover test, yet we're still replicating and protecting with a recovery point objective of seconds. So what I've shown you there is with those few clicks in the Create Protection Group workflow, you can protect your applications. And then in a few clicks more, you can do a failover test in working hours with no shutdown in production, no break in the replication, and see exactly if your application is recoverable in your DR sort and how long it would take. Which is why in the presentation I was emphasizing that this doesn't just have to be for disaster recovery. because if you have 100 Microsoft updates to apply to 200 applications, there's no reason that you can't start a failover test. Prove out that you can successfully upgrade all your Microsoft OSs. Once you've done that, you can click to stop the test. You can then go to your change request form and say, and when it asks, have you tested this? Then yes, you just have a few seconds ago using your replicated data and Zerto, which means it doesn't just have to be for DR. You can use it day to day to make your life easy. Because I like a live demo, let's actually go across to my SQL Server testing recovery and let's load the console and see what is happening inside this VM. My vSphere client is a little bit slow today, but we'll give it a little chance because we've got a few minutes more. And just as this is loading, if anybody's got any additional questions, feel free to start asking them now. I definitely think I need more RAM in this remote VM. So just as we're waiting for this, one important thing is, despite my challenges with the vSphere client, which is probably why it's now being replaced, is that this VM is a VM in the inventory with a console. And I could log into it, and for all intents and purposes, the services might have failed to start. This might be requiring some sort of domain controller services that in order to be recoverable. But the important thing is that because you can click to test any time, if this application is not recoverable, then you can find out in working hours and fix it. It's not going to be a DR scenario where you're finding out for the first time that you can no longer recover this application. So a quick question from Tom. Since you can do offsite backups from the replication data, can this potentially replace backups? And Tom, that's a great question. And yes, it certainly can. It depends on what your backup strategy is for and how you use them. So right now, if you, for example, simply use your backups for long-term retention of the data to a separate site, then because the Zerto backups are just a file on a file system, you could put them on tape, ship them somewhere for even longer retention, or just keep them in the recovery site to say, yes, I have copies of this data going back X number of years. If that's what you use backups for, then yes, certainly. So rather than try and wait for my vSphere client to come back to life because it seems thoroughly frozen, let's say, for example, I've logged into this console, I've checked that my application is working, and this is a successful DR test. In Zerto, we click to stop the test. And one important feature when stopping the test is Zerto asks for the actual user acceptance because we know that we successfully registered and powered on that VM, but we're asking, did the application actually work? And you know what? Actually, I'd be lying if I said success here because we couldn't log in and therefore I couldn't verify the application's recoverability even though Zerto successfully registered and powered on the VM in vCenter. So I can certainly select this as failed. You can then add a reason. And then once you click Stop Selected, what Zerto does is it automatically then deletes any changes that you made in the failover test virtual machines. It removes them from the inventory and automatically tidies up after itself, removing any trace of our failover test while keeping an up-to-date copy of the replicated data. I believe this vSphere client has frozen completely, so we're not going to see that operation from a vCenter perspective, unfortunately. But if we come back into Zerto, then we'll see the failover test operation cleaning up. And now my remote lab is definitely not happy. There we go. So if we expand Zerto out again, here we go. So you can see the cleanup operation is finished on my SQL test server VM and it's still replicating throughout. Now the next thing to show you is how you can report on this failover testing. And what Zerto allows you to do is produce PDFs that detail the outcome of this testing. And just to show you an example from a previous test that I did here, and bear with me 1 second, I'll just drag across my PDF. Then here you can see on a per protection group basis, you can see who did the test, how long it took, the outcome, the recovery site settings, and then the detailed recovery steps undertaken by Zerto. And you can also put your own logo in the top left-hand corner for good measure, just to keep everybody happy. So a question from Igor, and please everyone, that's wrapping up this webinar now, so any further questions you have, let's go through them now before we run out of time. So the question from Igor is, if Zerto can live convert VMs from vSphere to Hyper-V, how will it convert virtual hardware like Power Virtual Controller or VMNX3 adapters? So all we simply do is automatically convert all of the hardware to the equivalent in the target hypervisor format. So, for example, in Hyper-V, there is no distinction on the different controllers or the different network adapters. There's just Gen 1 or Gen 2. But if you fail over, we'll automatically convert it. When you fail back, we'll remember the previous configuration. If you're failing over, for example, from Hyper-V to VMware, then we don't actually use VMNX3 adapters because they do require VMware tools. We'll use E1000 adapters. But the important thing, Igor, is that if you're not sure on how your VM configuration is going to behave and what that conversion process will actually impact or how it will impact your applications, you can protect it, do a failover test, and see real time exactly how your application will behave and your VMs will behave if you were to recover them from VMware into Hyper-V. So just to wrap up, if anybody has any further questions, then I'll take them now. But thank you very much for your time this afternoon. I hope you enjoyed a little bit of what you saw, and have a great day.